Lesson 17.3, using a Pythagorean identity. Essential question: how can you use a given value of one trigonometric function to calculate the values of the trigonometric functions? Well, they're connected. Let's see, you got sine squared theta plus cosine squared theta equals 1. So if you know sine or cosine, you can solve for the other. If you have, then you also have tangent theta equals sine theta divided by cosine theta. So if you have one of these three, you can use it to find the others. All right, good. And let me show you how. Proving a Pythagorean identity. In the previous lesson, you learned that the coordinates of any point xy that lies on the unit circle where the terminal ray of an angle theta intersects the circle at x equals cosine theta and y equals sine theta, and that tangent theta equals y divided by x. Combining these facts gives the identity tangent theta equals sine theta divided by cosine theta, which is true for all values of theta where cosine theta is not equal to 0. In the following explore, you will derive another identity based on the Pythagorean theorem, which is why the identity is known as the Pythagorean identity. So, the terminal side of an angle theta intersects the unit circle at the point AB, as shown. Write A and B in terms of the trigonometric functions involving theta. So A is the x value, right? So this is going to be cosine theta. B is the y value, so that's going to be sine theta. All right. B, apply the Pythagorean theorem to the right triangle in the diagram. Note that when a trigonometric function is squared, the exponent is typically written immediately after the name of the function. For instance, sine squared equals sine squared theta. Sine theta squared is sine squared theta. So you're used to the Pythagorean identity. All right, so we'll do that. And that's a squared plus b squared equals c squared. No news. That's all right. Well, a squared is, well, that's the x value, right? Okay, that's the x value. So that's going to be cosine. I'm using the wrong color. That's going to be cosine theta squared. And then the b, that's the y, right? That's going to be plus sine theta squared equals, and then c squared, that's this right here, right? That's the radius, right? The radius, and that's 1. So it's going to be 1 squared. So you end up with cosine squared theta plus sine squared theta equals 1 squared. And that's what they're going to do down here. So I just want to, we're going to substitute cosine theta and sine theta, and then 1 squared, and that's going to give you cosine squared theta plus sine squared theta equals 1. All right. The identity is typically written with the sine function first. Write the identity this way and explain why it is equivalent to the one in step 1. So we've got, it's usually written sine squared theta plus cosine squared theta equals 1. And that's just the way it's typically written. And it's the same as the other one in the previous step or in step B because of the commute. I'm misspelling it. Commutative property of addition. All right. And basically that says 2 plus 3 equals 3 plus 2, which is 6, right? And we can agree with that. All right. Confirm the Pythagorean identity for theta equals pi over 3. So let's see. Sine pi over 3 equals the square root of 3 over 2. And cosine pi over 3 equals 1/2. 1/2. All right. So if you have sine squared theta plus cosine squared theta equals 1, then you're going to have the square root of 3 over 2 squared plus 1/2 squared equals 1. And let's see, the square root of 3 over 2, that's going to be 3/4. And then 1/2 squared is going to be 1/4, and that equals 1. All right. Confirm the Pythagorean identity for 3 pi over 4. So let's see, we're going to have sine 3 pi over 4 equals the square root of 2 over 2. And cosine 3 pi over 4 equals negative square root of 2 over 2. All right, so if we have sine squared theta plus cosine squared theta equals 1. All right, that's going to be the square root of 2 over 2 squared plus negative the square root of 2 over 2 equals 1. Well, the square root of 2 over 2 squared is 1/2 plus, and then the negative square root of 2 over 2 squared is going to be 1/2, and 1/2 plus 1/2 equals 1. All right, good deal. Good deal. Finding the value of other trigonometric functions given the value of sine theta or cosine theta. You can rewrite the identity sine squared theta plus cosine squared theta equals 1 to express one trigonometric function in terms of the other. As shown, each alternative version of the identity involves both positive and negative square roots. You can determine which sign to use based on knowing the quadrant in which the terminal side of theta lies. So if we solve for sine theta, we would subtract cosine squared theta from both sides and then take the square root, and you would have the square root of 1 minus cosine theta. If we solve for cosine theta, we would subtract sine squared theta from both sides, take the square root, and you'd have plus or minus the square root of 1 minus sine theta. Find the approximate value of each trigonometric function. I'll let you do A by yourself, and then we'll do B together when you get back. Given that cosine theta equals negative 0.906, where pi is less than theta, so that's going to be the third quadrant, right? 1, 2, 3, that's the third quadrant. Find sine theta. All right, so use the identities to solve for sine theta, and then remember you got sine squared theta plus cosine squared theta equals 1, and we're going to find sine, so we're going to subtract cosine squared. So you got equals 1 minus cosine squared theta, and then take the square root of both sides, and you got sine theta equals 1 minus cosine squared theta, plus or minus the square root, okay? Because right here we took the square root of both sides. All right, good. Now let's see, we're going to use this. So we're going to just put negative 0.906 in, square it, and we'll just put it in the calculator just the way you see it. And let's see here. You got go to calculate, control, and you got 1 minus, open parentheses, negative 0.906, close parentheses squared. Press enter, and you got 0.423. So we're going to have plus or minus 0.423. The terminal side of theta lies in quadrant, we did that a minute ago, it lies in quadrant 3, where sine theta is less than 0. So sine theta is approximately negative 0.423. All right, good. Suppose that pi over 2 is less than theta is less than pi, instead of 0 is less than theta is less than pi over 2 in part 2 of this example. How does this affect the value of sine theta? Well, if it's between pi over 2 and that's going to be quadrant 2. Okay, remember 0 instead of 0, that's quadrant 1. So suppose it is in quadrant 2 instead. How does this affect sine? Well, how does this affect the value of sine theta? Well, sine theta is the y value, right? And then, like this is quadrant 1, that's quadrant 2. The sine value is the y there. So it's going to be so sine theta will be positive. All right, supposing, how does this affect the value of sine theta? So it's going to be positive. Number 5. Suppose that 3 pi over 2 is less than theta is less than, so 3 pi over 2, that's going to be quadrant 4 instead of quadrant 3. All right, in part B, how does this affect the value of sine theta? Okay, quadrant 3 is over here, right? So sine is going to be negative. So sine theta is a negative value. All right. Explain how you would use the results in part A of this example to determine the approximate value for tangent theta. Well, let's see. Tangent theta is sine theta divided by cosine theta, right? All right, so that's going to give us 0.766 divided by 0.643, which is approximately 1.191. And it's just that easy. Number 7, given that sine theta equals negative 0.644, where, okay, pi, that's quadrant 3, right? Quadrant 3, so let's draw this little thing. 1, 2, 3, 4, and we're talking about cosine, so cosine is the x, so that's going to be negative, right? So we know it's going to be negative. So sine theta is negative 0.644. All right, so remember, sine squared theta plus cosine squared theta equals 1. And we know what sine is. We're trying to find out what cosine is. So that's going to be cosine squared theta equals 1 minus sine squared theta. Take the square root of both sides. And it gives you cosine theta equals plus or minus the square root of 1 minus sine squared theta. So cosine theta equals plus or minus the square root of 1 minus, and that's going to be negative 0.644 squared. And so cosine theta, and it's going to be approximate because it's going to be a long decimal. So we're going to have the square root of 1 minus, open parentheses, negative 0.644, close parentheses, squared, and that's 0.765. So plus or minus 0.765. Now we determined that it was here in the third quadrant. So and x is negative in the third quadrant. So we're going to have cosine theta equals negative 0.765. Given that cosine theta is negative 0.994, and then we're between pi over 2 and pi, so that's going to be quadrant 2. Find sine theta. Well, quadrant 2 up here, sine is positive, so it's going to be positive. Then find tangent. So we've got sine squared theta plus cosine squared theta equals 1. Subtract, we're looking for sine, so we got sine squared theta equals 1 minus cosine squared theta. Take the square root of both sides. You got sine theta equals plus or minus the square root of 1 minus cosine squared theta. So sine theta equals plus or minus the square root. That's going to be 1 minus negative 0.994 squared. So sine theta is going to be approximately, and it's going to be positive. So let's go over here. Control 1 minus, open parentheses, negative 0.994, close parentheses, squared, and that's going to be 0.109. So that's going to be positive 0.109. All right. Now we need to find tangent theta, right? Remember, tangent theta is sine theta divided by cosine theta. So tangent theta is sine theta, we found is 0.109 over cosine theta is negative 0.994. So let's see here. Control divide 0.109 divided by 0.994, and we know that's going to be negative. Enter. That's going to be 0.109. 0.109. So tangent theta is going to be 0.109, and that's in the second quadrant, right? 0.109. So we know that's going to be negative. All right, good deal. Moving right along. Finding the value of other trigonometric functions given the value of tangent theta. If you multiply both sides of the identity, tangent theta equals sine theta divided by cosine theta, you get the identity cosine theta tangent theta equals sine theta. Or sine theta equals cosine theta times tangent theta. Also, if you divide both sides of sine theta equals cosine theta tangent theta by tangent theta, you get the identity cosine theta equals sine theta divided by tangent theta. You can use the first of these identities to find the sine and cosine of an angle when you know the tangent. Example 2, find the approximate value of each trigonometric function. So again, I'll let you read through example or A, and then when you get back, we'll do B together. All right, given that tangent theta is approximately negative 4.66, where 3 pi over 2 is less than theta is less than 2 pi. So that's going to be in the fourth quadrant. Find the values of sine theta and cosine theta. First, write sine theta in terms of cosine theta. Use the identity sine theta equals cosine theta times tangent theta. So there we got it. Sine theta equals cosine. We can do it like that. There we go. So sine theta equals cosine theta times tangent theta. Substitute the value of tangent theta in. Well, we know that to be negative or approximately negative 4.366. Okay. Now use the Pythagorean identity to find cosine theta. So we got sine squared theta plus cosine squared theta equals 1. So we're going to substitute this in here. This in, since this is sine theta, we're going to substitute that in right there, and then we're going to get negative 4.366 cosine theta squared plus. So this is going to be 19. We're going to square negative 4.366 and get 19.062 cosine squared theta plus cosine squared theta equal, well, we'll add that to it and you get 20.062 cosine squared theta. Divide both sides. Let's see, 1 divided by 20.062 is approximately 0.050. All right, so 0.050. So, and then we're going to take the square root of that. So let's just do that in our calculator. 1, control, divide, 20.062, and that's going to be 0.0498. We're just going to round up to 0.05. And then we're going to take the square root of 0.05, and that's going to give us 0.223. So 0.223. The terminal side of theta lies in quadrant. We decided that was quadrant 4 there at the very beginning, where cosine theta is greater than 0, so it's positive. Therefore, cosine theta is approximately 0.223. And sine theta is negative 366. And so therefore cosine theta and sine theta, cosine theta is approximately negative 0.974. Okay. Well, therefore, cosine theta is approximately 2. So, and I think that was, this here was supposed to be, that should actually be tangent theta. That's a misprint. Well, no. What did it say? Let's see here. What did it say? Tangent theta was negative 4.366. So let's see here. I got a little happy. So tangent theta, and then that's sine theta. sine theta. All right, sorry about that. Okay, my book's a little bit mixed up. Number nine. In part A of this example, when you multiplied the given value of tangent theta by the calculated value of cosine theta in order to find the value of sine theta, was the product positive or negative? Explain why this is the result you would expect. Okay, well, let's look in here. It was positive. Calculated value of cosine theta in order to find the value of sine theta. Was the product positive or negative? It was positive. Positive. Explain why. Since sine theta should be positive, we're over here in sine. Since sine theta is positive in quadrant 2. All right. Number 10, if tangent theta equals 1, where 0 is less than theta is less than, so that's going to be quadrant 1. All right. Show that you can solve for sine theta and cosine theta exactly using the Pythagorean theorem, Pythagorean identity. Why is this so? Okay. If tangent theta equals 1, then sine theta equals cosine theta, right? Since sine squared theta plus cosine squared theta equals 1 becomes 2 sine squared theta equals 1. Which gives the result sine theta equals cosine theta equals the square root of 2 over 2. This occurs because theta is the special angle pi over 4. Number 11. Given that tangent theta is approximately 3.454, where pi is less than theta is less, so that's going to be quadrant 3. Okay, it's quadrant 3. Then find the values of sine theta and cosine theta. We know that they're both going to be negative, okay, because we're in quadrant 3, so that's going to be a negative and that's going to be a negative, right? All right. So let's see here. We've got tangent theta is 3.454. And so tangent theta equals sine theta over cosine theta. Well, I'm going to multiply both sides by cosine theta, and I'll get sine theta equals cosine theta tangent theta. Now, I'm going to substitute this 3.454 in for tangent. That'll give me sine theta equals 3.454 cosine theta. Now, I'm going to take that and I'm going to put it in. Remember, you got sine squared theta plus cosine squared theta equals 1. I'm going to put that in there. So I'm going to have 3.454 cosine theta and square it plus cosine squared theta equals 1. Now, if I square that 3.454, I should get 11.93 cosine squared theta plus cosine squared theta equals 1. I add that and I get 12.93 cosine squared theta equals 1. I'm going to divide both sides by 12.93, and I'm going to get cosine squared theta equals, it's approximately 0.0773, and then I'm going to take the square root of both sides. Let's get a different color here. Take the square root. And that's going to give me cosine theta equals plus, well, it's going to be minus because we already done it. So that's going to be minus 0.278. Okay, that's going to give me 0.278. So I can come back over here and sine theta equals 454 times negative 0.278, and that's going to give me sine theta is, let's see, 3.454 times negative 0.278. Is that right? Negative 0.278. Yeah. And press enter, and I get negative 0.96. So cosine theta is going to be negative 0.96, which is what we expected it to be negative because they were both negative up here, right? Because we're in quadrant 3. Okay. So there's your cosine, and there's your sine, and you got it. Good deal. What conclusions can you draw if you are given only the information that tangent theta equals negative 1? All right. Let's see here. Since tangent theta is negative, tangent theta is negative. Okay, and this is 1, 2, 3, and 4, right? So this is positive, positive. This is negative, 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 negative. This one is negative, positive, and this one over here is positive, negative. And that's the X, and that's the Y. So it has to be from quadrant 2 or quadrant 4. Must be in quadrant 2 or 4. Okay. Must be in quadrant 2 or 4. Because their sine and cosine have opposite signs, right? And since it equals 1, it said it equals 1, that means since tangent theta equals 1, sine theta must equal cosine theta. Okay. And let's see. So sine squared theta plus cosine squared theta equals 1. That would become 2 cosine squared theta equals 1. Divide both sides by 2, and that would give you cosine squared theta equals 1/2. Okay. Let's see, cosine squared theta equals 1/2. Take the square root of both sides, and that gives you cosine theta equals 1 over the square root of 2. And remember, you're not supposed to have that, so we'll multiply the top and the bottom by the square root of 2, and that will give us the square root of 2 over 2. Okay? So cosine theta equals plus or minus the square root of 2 over 2. And if cosine theta equals the square root of 2 over 2, then sine theta equals negative square root of 2 over 2. If cosine theta equals negative the square root of 2 over 2, then sine theta would equal the positive square root of 2 over 2. All right, good deal. Discussion. Explain in what way the process of finding sine and cosine of an angle from a tangent angle is similar to the process of solving a linear equation in two variables by substitution. Okay, say you had x plus y equals 3, and then 2x plus 3y equals, and we'll just say 10. Okay, what would you do here? Well, you would subtract. You might subtract y from both sides, and that would give you x equals 3 minus y, right? And then we would take this, and we would go substitute that in, 3 minus y plus 3y equals 10. And then we could solve for y, and we would solve for y. And then once we got our y, we would go back up here into our original equation and then solve for x, okay? We've done this before. We're just doing the same thing with sine and cosine and all. Not a big deal. Essential question check-in. If you know only the sine or cosine of an angle and the quadrant in which the angle terminates, how can you find the other trigonometric ratios? Well, if you know the sine or the cosine, then use sine squared theta plus cosine squared theta equals 1 to find the other. And then once you do that, then use tangent theta equals sine theta over cosine theta to find tangent theta. And then that way you can find all three real quick and in a hurry. All right, folks, great lesson. Thank you very much. I'll see you tomorrow in school.